We're going to talk about graphing rational functions now. Most importantly, we're going to talk about vertical and horizontal asymptotes. Now, if you remember back to lesson 8.3, we did y equals a over x minus h plus k. And we basically said that we were going to have an h was going to be x equals h was the vertical asymptote, and then k moved the whole thing up or down, and y equals k was the horizontal. But that would mean that our equation was always going to be written in this form, and then we just moved y equals 1 over x, h units left and right, k units up and down. Well, not everything's going to be in this form. So what we have to do is take a look at some different scenarios where that's not the case. And let me tell you, it's going to be a good time. Okay, so we start off with, you're not allowed to divide by 0. So what are you going to do to determine what makes the denominator 0? Well, you're going to factor the denominator. So nearly every time you do one of these problems, the first thing you're going to do is factor the denominator whenever possible. This one's, when you multiply together to get negative 12, add together to get positive 4. I think it's positive 6 and negative 2. Set it equal to 0 and solve. X equals negative 6, x equals 2. Well, really, this is what x can't be. So you can't be negative 6 and you can't be 2, which means if you look at your graph, the asymptotes would occur at x equals negative 6 and x equals positive 2. So to answer this question, which of these is not an asymptote? Well, x equals 6 is, negative 6 is, x equals 2 is, and then it gives us these two. And we're not sure on either one of them, but based on what we looked at in section 8.3, we can probably assume, since there's no plus or minus at the end, we can most likely assume that this one's going to be okay and this one's going to fail. And as the case is, this is the asymptote. If I remember correctly, this should look something like this. I don't know exactly what it looks like, but I think it might, and then I'd have to look at it. It'd be something like that. It's pretty funky. But this one does work, and we're going to take a look at why that works, and this is going to be the key. So the first thing is what we've been talking about, and this is a bunch of words, and we're going to look at all 4 of these scenarios. There's 3 horizontal asymptote scenarios, and there's 1 vertical asymptote scenario. So let's talk about the vertical one first. They're talking about a of x over b of x. So when b of x equals 0. So the vertical asymptote, all you're going to do is set the denominator equal to 0. And solve. And that'll give you the vertical, which, because you can't divide by 0. And then there's 3 scenarios for horizontal. And rather than just talking about them, it's better to actually do them. There's one scenario where there's no horizontal asymptote. There's one scenario where the horizontal asymptote is equal to 0. And there's one scenario where we have to simplify the lead coefficients. Okay, so there's 1, 2, 3 things that will happen. Let's take a look at all those, otherwise it's just confusing to talk about without looking at them. First thing we're going to do is we're going to state the vertical asymptote here, which is exactly what we just did on that first problem. All you're going to do is factor. I think this is minus 7 and positive 2. And so we know x equals 7 and x equals negative 2. So these are the 2 vertical asymptotes. Vertical asymptotes. Now when we get into horizontals, what we're going to do is we're always going to examine the lead terms. Now there is only one term up here, and its degree is 0. And there's the lead term down here. is this guy, and the degree is 2. And that's what we're going to be focusing on. The rest of it's not going to matter for horizontal. No horizontal asymptote. If the degree of A of x is greater than the degree of B of x, there is no horizontal asymptote. So this one, questions that you're going to get in the homework. Identify the vertical asymptotes. The vertical asymptote is when the denominator is equal to 0, and in this case it would be x equals negative 1. Horizontal asymptote. Look here, look here. This degree is bigger than that degree. What I like to do is kind of simplify it down, and I get x squared, right? And does y equals x squared have a horizontal asymptote? Nope. And since this is a higher degree, 3 is greater than 1, there is no horizontal tote. So you're just examining the lead term from the top and the lead term on the bottom. So it's kind of, if you simplify and you have a leftover x's on the top, you have no tote, no horizontal tote. Next one. If the degree of A of x, or the top, is less than the degree of the bottom, then the asymptote will always be y equals 0. Again, you're going to examine these two. Degree 2, degree 1. If the top is less than the bottom, then we have y equals 0. So the vertical tote here, you would have to factor plus 5 minus 3, x is negative 5, x is positive 3. That's your vertical totes. Horizontal tote, all you're examining is those lead terms, and it's y equals 0. Again, I like to pull it apart and say x over x squared. What would that simplify to? That would simplify to 1 over x. Hey, we had a whole section on 1 over x. And if we didn't move it k units, then we had y equals 0. So there's a direct correlation between that. Y equals 0. So you're just going to look for when the bigger degree is on the bottom, it's y equals 0. And the last one, when the degrees on the top and the bottom are the same. So we have degree 1 on the top and degree 1 on the bottom. There's a little 1 there. There's a little 1 there. All you're going to do is you're going to take the leading coefficients and simplify them, which in this case it's y equals 4 over 1, which is 4. Again, if you just take the lead terms and simplify them, you get 4. That means we have a horizontal tote of y equals 4. Vertical tote here is x equals negative 2. Okay, so now let's go back and look at this guy. Now it should make a little bit more sense. If the degree on the top is bigger than the degree on the bottom, there is no tote. So that's the top greater than the bottom. If the degree on the top is less than the degree on the bottom, you're always going to get y equals 0. And if the degree on the top is equal to the degree on the bottom, then you simplify the coefficients. Now, horizontal asymptotes have to do with end behavior. That's in the long run. As we go way out towards positive infinity, and for x positive infinity, and way out for x is negative infinity. Locally, around the origin, or around where the graph is doing its business, you can cross over a horizontal asymptote, but that's just locally. So this is end behavior, that is in the long run. State the horizontal asymptotes. Again, all we're going to do is take a look here. Bigger on the top, bigger on the bottom. If I don't remember the rules, simplify it. X squared over x is x. Does the line y equals x have any asymptotes? No horizontal tote. Vertical tote. X equals -1. There you go. Simplify. Degree on the top is equal to the degree on the bottom. Horizontal asymptote, y equals x over x, or +1. Vertical asymptote, x equals -1. If I expanded this out, the lead coefficient, or the lead term on the bottom, would be x squared. So I have the degree on the bottom is degree on the top is less than the degree on the bottom. Therefore, we're going to have a horizontal asymptote of y equals 0. Going to have a vertical asymptote of x equals -4. That's it. Enjoy.